This is the second part of 3.3, and we really need to cover proofs. Proofs are one of the things that folks struggle with the most here in geometry class, and almost all of my proofs are going to be in one specific format, and that's this two-column proof style, where we have our statements over on one side, and then the reasons over on the right. And the reason why we're going to do them this way is just so we don't, so it's the most common way here in our book, and so I just don't want to confuse you by doing a zillion different types. But for right now, you can think of almost all proofs in this format. And we always start our proofs with whatever information is provided. So the given information is this figure. We're not going to draw the figure, but this figure is part of the given information. And then this statement here. So in this case, the statement says triangle ABD. So triangle ABD is congruent to triangle ACD. So ABD is congruent to ACD. They're telling us these two triangles are congruent. So same size, same shape. They may be oriented just a little bit differently. And we have to come up with this. This is the quote-unquote the answer that we have to prove. And the thing we have to prove is that point D is the midpoint of segment BC. So we have segment BC here. And that's the thing we have to prove. So whenever we have one of these proofs, we can always write down the givens here. I will make tests where these are blank, and I will have students who fail to write down the givens, and it's just the easiest points ever. All you do is take the givens, write it down in this upper left-hand cell right here. And your reason for that in the upper right-hand cell is merely given, or givens, or provided, or something like that, just given. The other really easy cell to do on proofs is the bottom left cell. The bottom left cell is always this. Whatever you are trying to prove is in the bottom left. So D is the midpoint of BC, D is the midpoint of BC. These three cells should be super easy to fill out every single time. You fill out the givens, and you say given for your reason, and then whatever you're trying to prove will be provided as well, and you put that down here in the very last statement box. Everything else is going to be really hard to do because they don't give you a roadmap as to how you're going to prove that, right? In this case, for this example, there's a bunch of different tricks. I'll provide a link to another video that's really good about proofs, and we'll do lots of different proofs, and we'll build on it. But one tip I have for proofs is to try working backwards, right? So if we want to prove that something is the midpoint, well, how are we going to prove that something's the midpoint, right? Or how do we know it's the midpoint? Well, you can always go back to your definition of the midpoint, right? If we've functionally defined a midpoint, then we know that something is a midpoint. So that was our reasoning here. In order to define that something is a midpoint, you need to have a segment like BC where BD is equal to DC. So is segment BD congruent to segment CD? Well, yes, because these two triangles are congruent, and we know that corresponding parts of congruent figures are congruent. So this is our CPCFC. And if on a test, if you just put CP, CFC, I'll totally accept that. So now reading from the front, it makes a little bit more sense. It says, hey, we have these two triangles that are congruent, and that was just a given fact. Because those two triangles are congruent, here's my reasoning, I know that all corresponding parts of congruent figures are congruent. So here's an example of one part that's congruent. BD and CD, right? These are corresponding parts, therefore, of congruent triangles, therefore they're congruent. And then I can say, because I have these two segments that are congruent, I can say that D is the midpoint. So this is simply an example proof. Let's do a couple more. This one says, the given is that quadrilateral JKLM, so JKLM, is congruent to quadrilateral NPQR, right? So it's been flipped. We have to prove that angle J is congruent to angle P. Angle J is congruent to angle P. So how are we going to prove that? Oh wait, no, we were missing a step. I forgot. Angle J is congruent to angle K. So angle J is here, angle K is here. So it's saying that these two angles are the same, right? The lengths of these segments aren't the same, but the angle itself, it's saying, is the same. One way we can do that is using congruence marks. So I'm going to go ahead and mark on here. Since this is part of our given information, I know that those angles are congruent. So again, the three things I should be able to fill out every time are going to be this first one, moink, this one, moink, and this one, right? This is whatever I'm trying to prove, that angle J is congruent to angle P, and this is my given. Quadrilateral JKLM is congruent to quadrilateral NPQR. There's a second given here too, which is angle J is congruent to angle K. So I can give that. What are my reasons for those first two things? Well, it's given. So those are my reasons. Bam, right? I basically have only 3 cells now to fill out and figure out what they are. And it kind of holds your hands here by telling you what the statement is. Often these are left blank. Often this whole thing is left blank. But here it gives you the statement. It says angle K is congruent to angle P. So I'm going to go ahead and mark this one with blue. I'm going to say this angle K here is congruent to angle P. And we can think about this. We think, oh, how do they know that, right? We just have to come up with a reason. Why is it that angle K is congruent to angle P? Well, how did we know back here that side BD was congruent to CD? Corresponding parts of congruent figures are congruent. Hey, look at that. Okay, once we know corresponding parts of congruent figures are congruent, we can say that JK is congruent to, angle K is congruent to angle P. So that's the blue angles. So the red angles were given as congruent. The blue angles are given as congruent. So how in the world could we say that angle J is congruent to angle P? Let me color code these again. In fact, I'm going to mix this up a little bit. I'm going to erase this. I got purple. So that purple angle is congruent to this green angle, and this green angle is congruent to the, I've done that one, blue, green, purple, red, black, pink. Can I do pink? It looks weird, but pink angle. So therefore, it says that the purple angle is congruent to the pink angle. Let's think back. What are our properties of congruence? Which one is this? It's transitive. Yes, the transitive property of congruence. Remember back back here, our transitive property of congruence. So that allows us to say that these two things are congruent to each other. Cool, we did it. We're done. We got reasons for everything. We got all our statements. Let's do ahead and do 2 more. Let's start with number 8, and we'll go from there. See what we can do with that one. So try number 8. Do the best you can, and then we'll check and see how it goes. Okay. So pause it here. Okay, let's talk about number 8 real quick. So number 8, it's given that we have these 2 triangles that are congruent. It wants us to prove that ST bisects angle VSW. So again, you should be able to make a little table here. This one here, and this one here, and this one here should just be auto includes. You just plug in this. Over here you put given. Now the hard part's going to be what's in between here. What's the missing link? And again, I recommend trying to work backwards maybe. How do we know that ST bisects angle VSW? Well, we need to think about what does it mean to be a bisector, right? Specifically an angle bisector. Well, to be an angle bisector, it means that this angle has to be congruent to that angle, right? So that's our definition of an angle bisector, and we know that this angle is congruent to that angle. How do we know that those angles are congruent? Well, CPCFC. CPCFC. Number 9, we're going to do something very similar to our second example. On number 9, oh, I should have done another pause. That's okay. Same sort of deal though. We have two givens here. We have quadrilateral ABCD is congruent to quadrilateral EFGH, ABCD, and then we have EFGH. We know that that's a given. The other given is that AD is congruent to CD, so AD is congruent to CD. I'm going to mark this with tick marks this time. AD is congruent to CD. So we need to prove that AD is congruent to GH. So we need to prove, I'm going to do this one, this is what we're going to prove here. AD is congruent to GH. Well, how are we going to prove that? First, we can write down our givens. We can prove what we're doing here. And hopefully, as soon as you see something like this, you can think, oh, transitive property, right? If this thing is congruent to that thing and this thing is congruent to this other thing, then maybe the missing link here is that a missing piece for the transitive property, that this guy here is congruent to this guy here. How do I know that those things are true, right? So this is the statement here. How do I know that CD is congruent to GH? Well, CP-CFC again. So that fills in all of my reasoning, kind of working backwards. Okay. Last little question here. The student claims that any two congruent triangles must have the same perimeter. Do you agree? Well, two congruent triangles. What does it mean to have the same perimeter? Well, it means all of your outside angles, or not outside angles, outside sides add up to the same value, right? So here's our two congruent triangles. We'll pretend like they're perfectly the same. Would they have the same perimeter? Is this side equal to this side, which is equal to this, is this side congruent to this side? This side congruent to this side, and this side is congruent to this side. So yes, they would have the same perimeter. If triangle PQR is a right triangle and triangle PQR is congruent to XYZ, does triangle XYZ have to be a right triangle? What do you think? Yes, it does, because one of those angles has to be a 90-degree angle. So therefore, the corresponding angle also has to be 90 degrees. Suppose that you know that pentagon ABCDE is congruent to pentagon FGHJK. How many additional congruent statements can you write using corresponding parts of the pentagons? Well, we can do every single little part here. So how many sides do we have? We have 5. We can say that AB is congruent to FG and BC is congruent to GH, right? Every single little segment. We can also say all the angles. So angle ABC is congruent to angle FGH and angle BCD is congruent to GHJ. We can go through all 10. We can do 5 statements for corresponding sides and 5 statements for corresponding angles. Sorry, I can't see that. No. Yeah, so 10 total. We had it right. Cool. That's all I got. Good luck with the proofs. And remember to try that other link. The guy takes his time going through it, but it's worth listening to.